Hello and welcome to podcast.init, the podcast about Python and the people who make it great. When you're ready to launch your next app or want to try a project you hear about on the show, you'll need somewhere to deploy it, so check out our friends over at Linode. With their managed Kubernetes platform, it's easy to get started with the next generation of deployment and scaling, powered by the battle-tested Linode platform, including simple pricing, node balancers, 40 gigabit networking, and dedicated CPU and GPU instances. And now you can launch a managed MySQL, Postgres, or Mongo database cluster in minutes to keep your critical data safe with automated backups and failover. Go to pythonpodcast.com/Linode today to get a $100 credit to try out their new database service, and don't forget to thank them for their continued support of this show. The biggest challenge with modern data systems is understanding what data you have, where it is located, and who is using it. SelectStar's data discovery platform solves that out of the box with a fully automated catalog that includes lineage from where the data originated all the way to which dashboards rely on it and who is viewing them every day. Just connect it to your dbt, Snowflake, Tableau, Looker, or whatever you're using, and SelectStar will set everything up in just a few hours. Go to pythonpodcast.com/SelectStar today to double the length of your free trial and get a swag package when you convert to a paid plan. Your host, as usual, is Tobias Macey, and today I'm interviewing Nicolas Höning about FlexMeasures, an open-source project designed to manage energy resources dynamically to improve efficiency. So, Nicolas, can you start by introducing yourself?
Yes. Hi, Tobias. I'm Nicolas. I'm German and living in the Netherlands since 15 years. I've been a programmer for a bit more than 20 years, using Python for a long time. I've been working on energy since 12 years, I think, from that vintage point.
And do you remember how you first got introduced to Python?
First, I had been using very little C and Visual Basic. I've been working on Access databases and Word macros. But at some point, I did then go to university. During my bachelor's, I got to work on a startup. It was a neuroscience startup that is still around. It's called iQuant. The idea was to transfer neuroscience models of visual attention into a web application so that you can, basically upload your ad and find out where people might look first. And we use a lot of Python there. And I had to, I was sitting at lunch reading the standard Python tutorial so I could get to work on that startup. Still remember.
In terms of the FlexMeasures project that you are working with, can you describe a bit about what it is and some of the story behind how it came to be and why you decided that this dynamic energy demand response system is something that you wanted to spend your time and energy on?
Yeah, sure. And I'd love to. Yeah, it has become my life topic. I started a PhD around this topic in 2009 when it wasn't absolutely clear that we will get the kind of energy transition that we are basically in right now, driven by lots of renewables being the major source at some point. FlexMeasures, basically an energy management system. It helps you manage your energy. In the last couple of years, energy management has meant that you manage the data around your energy, metering data. You put it on nice dashboards and you do billing around it. That's also significant work to be done. FlexMeasures focus is more on the energy flexibility and optimizing when energy is consumed during the day. Because that's a very important piece in the energy transition. As any expert will tell you, we'll need to get to this kind of optimization at some point. Otherwise, we will not get the fit between available renewable energy and the actual consumption to have a stable energy system. So FlexMeasures helps you find the best times for your flexible energy assets. Let's say a battery, that's the best example of a flexible energy asset. When should that battery be charging or discharging? The other examples for flexible assets are heating. You can heat sometime before you're really home, for instance. Heat pumps are a big topic. In industry, you have a lot of potential to run energy-intensive processes at a slightly different time. And FlexMeasures really helps you model all your energy data in real time and make that decision.
You mentioned that a number of the other energy management systems are focused more on a kind of one-way path of information where you're just retrieving data from the system and then using that to build some analysis, but that doesn't get acted upon in any sort of automated fashion. I'm wondering if you can just give a bit more of an overview of what the space looks like for these energy management systems and if there are any kind of alternatives to FlexMeasures or if it's something that is relatively unique in the space.
There are some projects that have on the roadmap to also do this kind of real-time optimization. But you got a lot of inertia in these projects as well in companies. So I see a lot of companies who had to start basically going to customers who have not even any metering installed whatsoever other than having a main meter. And the main meter's data is not real time as well. So these companies started with bringing in their Raspberry Pis or whatever it is, becoming good at that, starting to measure, becoming good at visualizing information, becoming good at doing them some aspects of billing maybe. And to do this step into data science and optimization, I see the difficulties in some organizations to that extra step. So these people are happy to get some other project, get some other help with that. I don't know all the projects out there, of course. So FlexMeasures is open source, and another open source project that I know about is just called OpenEMS. That's a Java project originated in Germany. That's built a quite interesting foundation around it. But also there's a big focus and inertia on getting the metering and visualization correctly done. And there's not so much support yet to optimize what actually happens and influence that. And we have decided to only focus on that.
As far as the primary focus and goals of FlexMeasures, I'm wondering if you can just talk to some of the kind of outcomes that you're aiming for and some of the, I guess, target audience for the project.
As a big goal, the big hairy goal is that FlexMeasures should really help to speed up the energy transition and become one of the standard pieces of climate tech, infrastructure tech that you would also always consider when you start a new modern energy project where your real-time optimization is a part of the solution. The main way I think FlexMeasures can help is really being a developer-friendly tool to solve a lot of these things that take you weeks of work. Get your data model right, get your data integrations right, get some monitoring right, decide how to implement where your algorithms should be run, have a queue for that, processing queues. And there's all these things that developers now will keep you busy before you get to the real use case, before you really help your customer, or you're implementing something very shoddy, very quick hack. See that happening a lot. A lot of people asking their cousin's neighbor to have a simple algorithm put somewhere, but this is about real-time data pipelines who have to be kept alive and be checked on health. Yeah, I think we succeed if developers around the world, who I expect in the next 10 years to be looking around how they should approach these similar challenges, to always consider FlexMeasures. And that can be in a startup somewhere. That can be in a larger energy company where they have already their ICT team, but haven't solved or started to do this yet. And I think this is a problem that happens in all the parts of the energy system. For me, there's two big parts. That's industry and what's usually called smart city at the moment. So anything in the built environment. Those are two huge sectors of the energy sector, which in itself is one of the biggest sectors in the world that needs to undergo the most rapid transition you could imagine. The plans are 15-year plans basically to change how everything works. So we really hope FlexMeasures can help get that super big vision done in time.
Do you also see FlexMeasures as something that an individual homeowner might use as part of managing their energy systems, particularly as more people invest in solar and small-scale wind?
Yes. I want to talk about a small project we've been doing. So besides working with customers or with companies that can scale up innovation, we've seen that this is still slow, right? So these companies all have to think differently before. They haven't been involved with energy so far. It's a long process. So we have on the side created a living lab with just one household, with someone who's also very enthusiastic about specifically vehicle-to-grid charging. They bought the exact car and the exact charger that can do that already, the one that is allowed to do that in the Netherlands. And we've really implemented the automated optimization of the charging and discharging in his house. And for that, we needed to actually do something in the house. FlexMeasures is basically supposed to run in the cloud. It's Dockerized. It can also run locally, but it basically makes decisions. It doesn't really show you something. So I want to pitch a very cool project that's called Home Assistant. It's also open source. It's also originated in the Netherlands, but they have a company in the US also now. Very interesting group of people, basically in the home automation sector with their software. We used Home Assistant together with FlexMeasures to automate the charging, discharging, and taking into account the solar panel production to really create a cool project. We also open sourced our Home Assistant plugin. So that's out there. We were on Dutch TV and a couple of people wanted to use it as well. And now there's this week the first 2 others who've implemented it in their house. So now we have 3. But for us as a company, that's not the focus, but it's where you can really do something right now and really show something. And there's always these enthusiasts that just want to build something in their house like that.
As far as the overall question of energy systems, I mean, that can be, it's a very broad term with a lot of different, I guess, energy sources and use cases kind of embedded in it, where one element of it is the electrical grid, another is the usage of fossil fuels for transportation and shipping. There's home heating, there's heating at, industrial scale for large factories. And the majority of those, I guess, ecosystems of energy usage are governed largely by different market forces, where there is the, energy producer, which is becoming a bit of a fuzzy line now, with more homes and residential and industrial installations having their own energy generation through things like solar and wind. And then there's the energy consumer and the distribution system, and the pricing of those different resources are governed by, some level of dynamic usage where, there are peak loads. And so that can increase energy prices for certain periods. And I'm wondering what you see as some of the benefits that FlexMeasures can provide to this marketplace ecosystem, particularly given the fact that it's not as clear-cut now as it once was.
You're absolutely right. It's a vast, sometimes confusing system. I like the analogy that because somehow it's all connected and it has to happen in real time, and the frequency of the grid, as far as electricity is concerned, is held in some synchronization. We've created the largest man-made machines with the grids. So you got the US grid, the European grid, and the Asian grid, basically, as the largest 3 machines you could even imagine, where your house is a part of it, or the electric assets, and it happens in real time. Different markets buy and sell and allocate energy for different horizons. And FlexMeasures is certainly not very useful in the range of, let's say, you're buying your energy a couple months ahead and buying these big budgets. Also, I wouldn't say it's usable in the second range. There's some balancing markets to get this frequency challenge on the grid right, where you have to react within a second. But everything in between, where you have to react basically during the day, or you think in the evening about your plan the next day, that's where FlexMeasures is really useful. And as I said, it's really on the electricity range where we want to use it. So if you're a consumer, you can use FlexMeasures to use greener electricity or help the grid stability. But I think mostly what people care about, of course, is to have their energy bill in check. The spread on market prices has gone up. Energy bills are rising a lot. So there's a lot of urgency, I think. Now there's clarity that this is very important for them to achieve. And from a grid perspective, if you're a network operator, it also is great if a lot of decentralized decisions are happening that help the grid stability. We have to follow what renewables are doing to a big extent, more and more. We cannot influence when we get that solar power or wind power, but we can influence when we use power. And if a lot of decentralized decisions are being made to shift their consumptions towards when renewable energy is really there, we get a more stable grid. And the only other solution for network operators would be to, double or triple every cable in size. So this is a big societal cost saving we can achieve with installing better decision making in the nodes. which turns how the energy system works on its head. Right? So still now in the last decades, we have optimized a few power plants per country and just forecasted what consumers will be doing. And now that's partly turned on its head. It's very interesting.
Digging a bit more into that question of renewables and their broader distribution, particularly with residential installations as part of that mix, I'm curious what you see as some of the broader impact on the way that the kind of marketplace economy around electrical grids in particular is likely to shift as the power generation and power distribution becomes bidirectional on a more routine basis.
One thing we see in the Netherlands, and I think that the Netherlands are a bit ahead on the curve there, is more dynamic prices. I think you can choose between 5 suppliers now that will buy power on the day-ahead market, which has 24 different slots. But then they will just give you those 24 prices. So the afternoon before, you will know what your 24 prices will be the next day. And if you have some optimized system like what we did, for instance, in the vehicle-to-grid project, that's going to turn out quite well for you then. You will not consume energy when those prices are high. Of course, what's interesting is that this might create more of a divide between those people that can afford that have this cool infrastructure plus software, and they get their average energy bill, well, they keep it low, let's say, and who's going to pay a lot? That's probably going to, if everything goes like this, it's going to be the poor people. So this is outside of the technical realm, also very interesting political discussion where we still have some time. And I'm also involved in some of these discussions to discuss how we can achieve a more just way to do that. What we really need is not for individual homeowners to invest in their own house and make it smarter. I like it. I'm enthusiastic about it when it happens. But what we really need is this scale. We really need to do these things for everybody on a big scale. So, for instance, big housing corporations already know, given their ESG strategy, they have to renovate at least 4% of the whole portfolio every year. And every year that they don't do that, it's just getting to be more pressing, like 5%, 6%. And then, you need to make a whole neighborhood or a whole big flat react to flexibility demands from the grid. And that can be very exciting that you then, for instance, have one giant heat pump for a whole flat. And especially if you get to bigger numbers, there will be a better way to react. For instance, it's almost impossible to forecast for a single house when you will be home, when will you cook. You can have a little bit of an idea, but if you forecast 100 consumers, you get a much better data forecast, which you can really work with. So I think that's really what I need to see, these bigger scaled approaches. And I hope FlexMeasures can be helpful with that.
Digging into some of the way that FlexMeasures operates, I'm wondering if you can talk to the sources of data that you're looking at, some of the ways that you manage that integration and processing, and the types of interaction that different kind of users or operators might have with FlexMeasures, and how much of it is just you kind of set it and forget it.
Yes, sure. So my simple picture of FlexMeasures is data in, scheduling out. Data in means certainly metering data. You want to know what all your assets did in the past. So it can be very useful to, for instance, for a battery, know the possible state of charge it has now. It can help to forecast what will happen in the near future. We also read in prices, market prices, for instance, the next day. Weather forecasts. So you can then forecast your solar generation if that's on your roof. Sometimes the occupants' plans are also data that you need to take in. So in the vehicle-to-grid living lab, in this application, the occupants' data might be that they say they will need the car for a longer trip tonight at 6 p.m. That's important data that influences the scheduling because the car should be 100% full by then. Or in a factory, they also have new constraints every day, how much processing work they need to be doing. That's about the data. And you said earlier that set and forget might be an interesting concept. I really agree. For most people who will live in modern energy environments with some optimization happening, they should not even care about that during a normal day. So in the vehicle to grid project that we've been doing, that really was also a design goal. It worked. And from then on, it just quietly optimized every day what the battery was doing. We did, however, in that project think you might want an override button. You might not want to meddle with what exactly the optimization is doing, but it's nice, of course, in an optimized system to have the ability to say, just stop what you're doing, or the other button says, charge the car now. I don't care about the price or whatever. The idea is that these buttons are almost never used, but they should be there. So I think that end users who live in these built environments should really not be involved that much. And it's more the servicing around that. So FlexMeasures needs to be hosted, and we need to check that data is always flowing and check with every error that might come up in the scheduling. And you have some companies that are called energy service companies. So a lot of them, for instance, have these more traditional energy management systems I talked about earlier. And I think that they would be users of FlexMeasures. If we don't do it for them, they would really build it into their monitoring pipeline, have a KPI and reporting pipeline to regularly check if that's happening correctly. One thing that's nice to check is the Universal Smart Energy Framework. It's called USEF. My co-founder was on the design committee, and they talked about the different roles in modern smart energy system. You mentioned the prosumer already. I mentioned the energy service companies, and you also have companies that are called aggregators. They aggregate the energy flexibility from a lot of customers into their virtual power plant and just trade that flexibility on markets. I think you could build energy aggregator using FlexMeasures, but that's not what we do. We use it for optimization behind your meter.
As far as the actual implementation of FlexMeasures, I'm wondering if you can talk to some of the design considerations that went into it, some of the challenges of being able to flexibly manage scale of inbound data and the types of requests that you're getting. And also, I'm interested in maybe some of the capabilities of being able to federate across different installations of FlexMeasures and, route different decision requirements or different data points based on different kind of inbound information.
So from the beginning, a few years ago, I think I didn't mention that before, but the first project where FlexMeasures really got its first development time, that was with a South Korean customer called A1 Engineering. They wanted to do simulation first of a system with a lot of smart charging, but then also move to real-time operation in a later phase. So this is the main design idea that has been there from the start, that you can use something in reality, in real operation, but it's also useful initially in a phase where you are simulating what might actually happen. And that's still very relevant. So we're doing a simulation with a bigger real estate company right now. That's their first step. I think that main design goal still stands. Now, we haven't used multiple FlexMeasures nodes and federated the decisions yet. So I think that could be built, like a lower level of FlexMeasures instances, basically governing smaller installations. And another one, maybe trying to aggregate. As I mentioned earlier, that's a concept of the flexibility aggregator, and aggregate across those behind the meter installations. That could be a higher level FlexMeasures instance. Yeah. Now we haven't done that yet. We consciously can decide not to, let the volume of data grow too large. So for instance, you might run into projects where they have 10-second interval readings, but to make the kind of decisions that FlexMeasures needs to make, let's say on an hourly basis or a 15-minute basis, you don't need to read in the finely structured data. It would be best if that other system gives us already aggregated data, for instance, in 5-minute steps. That will be fine. And then the amount of data isn't growing that much, but we're already looking into that. So our data is stored in Postgres. And of course, that we also made that choice because you have so much support for growing bigger with your databases and have all these clustering strategies and sharding. And also, of course, there's interesting technology built upon Postgres. I think one of it was called Timescale DB that really focuses only on the time series aspect. And one thing that we considerably put some effort in is to model this data because it comes, as you said, from different sources. There might be a company that installed the sensors at the factory or is responsible at the houses to measure what's happening. So weather forecasting service. So we use Open Weather Map. FlexMeasures can read data from there. The European transmission system operators have a service, an open, transparent API as well. So you got multiple sources. They all send you data that might be about different things. It has different time zones. It's crucial to maybe know when they know about that. So not only the time that they're talking about, one point in time with one measurement has one date time, of course, about the time that you're talking about, but we're also interested in the daytime when they said this would happen. If it's before the time, this is a forecast. If it's after the time, it's a measurement. That can be quite useful when you write optimization algorithms. All this led us to write our own, basically, time series data model. We called it Timely Beliefs. It's actually an extension on pandas. So what it makes possible is that you have a pandas data frame, or basically a class that extends from pandas data frame, and we call it a beliefs data frame. We wrote a lot of functionality around that you can merge these data frames or change the resolution or whatever. It's a very interesting project that took a lot of our time, and now we're profiting from that within FlexMeasures to really understand all the time what that data really means.
As far as the kind of architecture of the project, digging a bit more into that, I'm also interested in understanding the kind of extension points that you've built to be able to allow different users of FlexMeasures to adapt to different data sources, or being able to extend the types of decisions and machine learning capabilities that they want to use, or the types of predictions that they want to generate, and maybe a bit more of the kind of data integration and kind of predictive capabilities that you've built into it.
FlexMeasures is extensible with plugins done last year, and we are using that ourselves because often every project has these differences, different data sources or needs. Often it's also the visualization that you want to adapt to a customer. So that's very important to the whole architecture, that you can add your own API endpoints, even your own visualization. And we have a command line interface. You can even add your own command line interface commands. For instance, one that regularly gets data from some other open API, and you want to run that hourly in a cron job as a FlexMeasures command. FlexMeasures actually is built on Flask, and Flask has some nice capabilities for that. Of course, for APIs, but also it integrates with Click, so command line interfaces are nice to write. And with the Flask blueprint technology, it was quite a joy to write our first plugin architecture. So what you do in the plugin is mostly add a blueprint to FlexMeasures. Flask has its CLI command, and we renamed that to FlexMeasures. So yeah, it all ties back into what I said earlier. We want FlexMeasures to be usable by software developers. And then, of course, APIs are super important, but also the command line interface, I think, is super important. We wrote a tutorial how you would use FlexMeasures within a few minutes, just to show you within a few minutes what you might be doing, which is based on Docker. So you don't need to install all these things. You just pull the Docker image. And then that tutorial is a few calls to the command line interface about modeling that couple assets, that you have a battery, for instance, loading in some data from a CSV file, and asking FlexMeasures to compute a great optimized schedule for the next day. That's all command line interface command. That's what I really like. Optimization in the background happens, I think we use Pyomo. It's also a very powerful library for these kind of things. And there was some sklearn that we used, but recently we've picked up skTime, which is really a package focusing on time series forecasting, doing smart things around that. And it's very nicely done, it seems.
As you have been building FlexMeasures and iterating on the problem space, and also with the donation of it to the LF Energy Foundation, I'm wondering, what are some of the ways that the design and goals and scope of the project have changed or evolved since you first started working on it?
I said earlier that actually the overall design goal to make both simulation and optimized real-time operation possible from the same code base is still intact. I liked open sourcing FlexMeasures. It happened roughly, less than 2 years ago. We hit that button in GitHub, and a couple months later donated to the Linux Energy Foundation. I liked that pushed us to even more transparency and even more having a focus on code quality to make sure that Lake 8, MyPy, and Black always run. It's always looking good. And documentation got a lot of boost. And also, in the meantime, we did once make big changes to the data model. When we worked for industry customers, we noticed that our initial data model was a bit too simplistic. I think we modeled power, weather data, and prices. And if you go to industry, you quickly realize they want to measure a lot of other things that all have some influence on your outcomes. For instance, you might be measuring steam flow, and that wasn't possible. So we took a lot of time to make our data model more generic, and now we can model anything.
Another interesting aspect of the kind of open sourcing question, and it's addressed a little bit by your donation of the project to the LF Energy Foundation, but I also know that you are running a business where FlexMeasures serves as a kind of central portion of what you're providing at Seita. And I'm curious if you can talk to some of the ways that you think about which pieces of your work you want to put into the open source FlexMeasures project, and what are some of the other kind of capabilities or layers that you're building on top of that are part of the kind of commercial and business focused offering?
It's a very interesting time to have a commercial open source startup. I was recently involved in an accelerator on the US side. I had to attend at night, always at 11 p.m. But there's really some investors in the US that are looking for open source companies to invest in, because you got, in the last couple of years, some really interesting examples, mostly on the database developer tooling side. So obviously in the energy sector, this is quite new. But it's clear that you can run a business even if you're very open. Linux Energy Foundation advised to use permissive licenses. So in this case, we use Apache 2. You could also use MIT, for instance, over copyleft licenses, because the idea is to just open the doors wide to growing the community, letting other people use the tooling you write, even if they don't really even tell you about it. They should have no doubts that they can use it freely, because you want to just grow. That's after the Linux Energy Foundation told us that they use those licenses. I also heard it from this venture capitalist accelerator program. It's a very interesting vision on innovation, on open innovation, that this might be one of the future scenarios that comes true, right? That the pull of open source innovation becomes as big in other sectors as has become in databases and developer tooling. Nonetheless, we have made FlexMeasures possible to create plugins. And oftentimes the customer says, if you're developing something here about our processes, I don't want that to be public, or if I pay you to do something, I don't want it to be public. And with the plugins, that's very possible, of course. Then you have FlexMeasures as an open platform, and also Timely Beliefs is open. And we occasionally open up other projects that we work on. For instance, I mentioned that Home Assistant plugin in the Vehicle to Grid project that's open. I think we have a couple closed repositories lying around right now with work for customers. Something that's maybe not ready for the world will always happen.
I'm also interested in understanding a bit about, given the kind of predictive and machine learning focused capabilities that are part of the FlexMeasures platform, and the fact that you are building predictions about and potentially acting on information regarding people's energy usage and energy capacity. What are some of the challenges that you face in terms of accounting for whether to bias towards false positives or false negatives, and what levels of uncertainty you're willing to accept in some of those predictions and decisions that you make?
Yeah, that is a very interesting topic to go into. It's difficult to answer without having even more experience. We had a project trying to find out if forecasting should be done with something very sophisticated. You can use linear regression to forecast, let's say, the solar production, ARIMA models, but you can also use a neural network. We found that the neural network isn't really that much better, and you don't know what's going on. And just recently, I saw a paper come by that some researchers even confirmed that. So for time series forecasting, currently there doesn't seem to be a reason to become very sophisticated. What we did do was we saw that there is algorithms which tell you about the uncertainty that lies in the prediction. So it's mostly ensemble algorithms like random forest. They have a lot of forecasts and then make a mean forecast, but they tell you how far all of the others were distributed. And that information can potentially, of course, be useful for exactly your question, that you know that some forecasts are shaky, and you might decide for a scheduling algorithm that there's a policy of not acting in those situations. And that's something I didn't mention about the timely beliefs data model. One column in the belief data frame is the uncertainty. So how certain forecasts, for instance, would be. It reminds me of a setting we have in a scheduling algorithm right now. For the battery charging, one property you need then is round trip efficiency. So you can discharge a battery. Let's say you discharge 1 kilowatt hour, and then you charge that back. Let's say the other way around. You charge it first, and then you discharge it. And you've made some arbitrage because your 24 hourly prices had this nice difference, or that's some difference, but the battery is not 100% efficient. So you end up maybe that it's 80% efficient, could become 90% in some batteries. So you're losing some of that power in that process. And it's very important to model that so that the scheduling algorithm then sometimes does nothing. Price difference is too low, then it doesn't make sense to do all that. So sometimes the schedule is to do nothing, even if there's some price differences. And I see the policy of doing nothing if the uncertainty is too high, and that's a similar thing.
In your work of building FlexMeasures and working with different companies to help implement it and providing it to the community and working with people who are using it for their own purposes, what are some of the most interesting or innovative or unexpected ways that you've seen FlexMeasures applied?
There's not that much, but there was a project where FlexMeasures wasn't even being used for any scheduling, which is basically the end goal of using FlexMeasures is to have a schedule and then change the times when you do use energy. And in that case, it was a project where it was just so useful to use FlexMeasures to just be a plain energy management system, getting all this data together with data pipelining being done quite fast, but then not doing forecasting, but in doing something else. There was a different algorithm that was basically some advanced analytics. And it didn't really have to use electricity. It was about gas consumption in industry. So that is possible, but that's not where I want to take it.
In your work of building the project and building a business around it and donating it to the community, what are some of the most interesting or unexpected or challenging lessons that you've learned in the process?
Something that you have to learn on your own is how long it takes to integrate data that constantly flows and that has these intricacies that I mentioned earlier about time series that you could get slightly wrong. It could be you get the time zone slightly wrong, or somebody sends you data that isn't localized. You might be 1 hour off half of the year. Your whole schedule will not be good. They also might send you data that gets the daylight saving time wrong, and then there might be 2 hours in the year where you fail when daylight saving time is switching back and forth. And yeah, the sheer amount of attention and work that gets into that is quite staggering. We had an industry client with a partner who does their sensoring, and they didn't have the API ready for us. So that was not what I had expected in 2021 from that kind of player. What we could get from them was emails with Excel spreadsheets. And we decided that they send us 3 per day. So every 8 hours, we wrote a FlexMeasures plugin that has its own command line interface command to just handle that email and get the data in. And yeah, you can imagine that prolonged that kind of pilot considerably.
Yeah, it's definitely remarkable how much of modern data engineering and data management still relies on CSVs and FTP.
Yes, absolutely. And if you look at the energy sector as a whole, that these kind of experiences are one dimension towards the realization that there will not be one end-to-end solution that can be used across a whole country or across a continent that will just take over. We have to build a lot of unique end solutions. Let's call them apps that work differently in different energy systems, countries, cultural contexts, sectors. And I think FlexMeasures can be a basis for all of that, but you always need to put something on top that really fits to that situation.
For people who are interested in being able to gain some more insight and potentially act on the different aspects of energy usage, whether it's at the residential or industrial or grid scale, what are the cases where FlexMeasures is the wrong choice?
I've mentioned that earlier, but there's some people who have to act within seconds. And that's usually if you're really taking part in this first reserve mechanism, reacting to balancing problems, frequency things. And we have put a lot of focus on FlexMeasures to be developer friendly and correct about the data so that developers really understand what they're building. And we haven't made it, a Rust project that lets you do all that within seconds.
As you continue to build and iterate on the project and continue to iterate on the business that you're building on top of it, what are some of the things you have planned for the near to medium term or any particular problem areas that you're excited to dig into?
Yeah, so first about the FlexMeasures project, I think what we really could do with that project is to support the 2 groups of users that I see in what they are doing as their first steps. So I see the first group as being the 90% users who have a use case that really happens a lot in the world, and FlexMeasures should support out of the box that the optimization for that use case can be done within a few hours. Data integration plus having that optimization work should be a few hours. So that's a little bit of a benchmark. Let's say, as an example, somebody has solar on the roof and there's somehow a battery, a home battery or an electric car, and they have a dynamic tariff. That might happen a lot in the next years across the world, something like that. And that should just work. And basically that does work. Now what we have to do is documentation and write an excellent tutorial so that everybody could do that. And there's probably a list of 4 or 5 more of these situations that should just work. And the other group of users are the power users that really have a unique problem and may come with their unique idea of solving it. And then I'm talking mostly about the algorithms. Right now, you can already plug in your own scheduling algorithm. Or to be honest, at the time of recording, that is a PR I'm having reviewed. But that's really important for some people. That's researchers, certainly. That's their whole line of work, to come up with better algorithms. Maybe find that neural network algorithm that really does make the difference. But you see that also in some companies who really have, certainly in industry, they just have their unique challenge. And they should be using FlexMeasures, as is, and then just change that one thing, that there is a common interface with how the question to make a new schedule is described, but they could, in the back, just switch out the algorithm that is used to make the schedule. I think these two groups of users deserve each of their own a dedicated tutorials by us to really make it clear, to make it a joy to do. So much as our work, I mentioned two sectors that we're working on. The industry world is very interesting and challenging, but it's also very diverse. Right now, built environment is what excites me the most, and I'm talking to companies there that really understood the scale that I mentioned earlier. They have renovate or really modernized their whole portfolio within a very short amount of years. So scale is their big topic. And the third thing I didn't mention is microgrids. So microgrid is your own little electricity grid that is connected maybe to the main grid or not, completely run on its own. And that's a situation that we might see all across the world. So there might be more self-serving neighborhoods that are not completely dependent on the grid in Western countries, but certainly in Africa, that's something that's just the one way to go for a lot of regions. There's some interesting companies there that I hope to do more with in the near future, because FlexMeasures should be able to basically run a small village. You might think there's too many assets, but what really matters is the flexible assets. So that's where that defines how much FlexMeasures has to do, how many flexible things are there. E-mobility is making huge steps in Africa, certainly. We're hoping to be involved in a project in Victoria Lake where all the fishers get upgraded to electric boats, for instance, and they use energy for productive uses, like cooling the fish they caught, water purification. That's all flexible. It's all something you can shift around in the day. And then FlexMeasures can really help, for instance, in the design phase already, to not buy oversized equipment. I don't think you will become rich in Africa, but that's something I'd really like to be involved in.
Well, for anybody who wants to get in touch with you and follow along with the work that you're doing, I'll have you add your preferred contact information to the show notes. And so with that, I'll move us into the picks. This week, I'm going to choose the show She-Hulk from the Disney Plus. Just a fun and goofy show. Some interesting storyline there. So I've been enjoying watching that. So recommend that for people who are looking for something to do in the evening. And with that, I'll pass it to you, Nicolas. Do you have any picks this week?
Yeah, I'm watching a very nice German series on Netflix. It's called Cleo, Kleo. It has a bit of Kill Bill visuals because it's an ex-agent from the East German Ministry of Defense who got thrown into jail, and she comes out of jail right when the wall has been torn down and tries to find out what happened, who did it. It's not just Kill Bill, but it's also charming and funny.
Thank you very much for taking the time today to join me and share the work that you're doing on FlexMeasures. It's definitely a very interesting project in a very important area of effort. So I appreciate all of the time and energy that you and the other contributors are putting into that. And I hope you enjoy the rest of your day.
Thanks, Tobias. It was a joy to be here.
Thank you for listening. Don't forget to check out our other shows, the Data Engineering Podcast, which covers the latest on modern data management, and the Machine Learning Podcast, which helps you go from idea to production with machine learning. Visit the site at pythonpodcast.com to subscribe to the show, sign up for the mailing list, and read the show notes. And if you learned something or tried out a project from the show, then tell us about it. Email hosts@pythonpodcast.com with your story. And to help other people find the show, please leave a review on Apple Podcasts and tell your friends and coworkers.